Hello, you're welcome to Ekidel. We are to infrastructure civil and structural engineer. My name is 𝔼𝕟𝕚𝕚𝕝 and I am your instructor. Today, I will be showing you the structural modeling of this building you are seeing here. Okay, so by the end of the day, you will be able to know how to model this structure here, and the software that we will be using for the structural design and modeling of this building is Protastructure. If you want to learn structural design, then Ekidel is the best for you. By clicking the link, you are already one step ahead. Don't miss this offer. Enroll now. Right? So right now, on our previous part of this video, we performed the structural framing, as you can see that. So we performed the structural framing, which we did the column positioning, and also we did the paneling and also the beam arrangement, and also we did a superimpose of the column onto the first floor to know if there is a difference on the building plan, but unfortunately there is no difference and all that, so that's fine. But just that we had some columns that we are meant to change the size on the first floor during the modeling, which is now on red. Okay, so right now we will then move on to the structural modeling of this building, and we are going to use the Protastructure. Okay, so we are going to work hand in hand with the CAD file here as we perform the structural modeling, okay, of this building. So if you have not gotten the CAD file, you can check the link down below and get the CAD file and practice with me here on Ekidel. Okay, and the CAD file is very it's not expensive, it's just $1, so you can get that for yourself and do yourself good to practice. Okay, that's fine. So, and also we are currently running 50% discount on our Ekidel mentorship. So if in case you want you have been wanting to join Ekidel mentorship, this is the only last chance you have to join that, now that we are still under promotion price, and it will end this month of April. So by the by next month, beginning May, is going to come back to its normal price. Okay, so I will advise, if you are interested in Ekidel mentorship, it is time for you to go and make use of this chance where we are offering this discount. Okay, that's fine. So with this, now let's now begin with the structural modeling, okay, using the software Protastructure. Okay, that's fine. So with this now, once you're done with your structural framing as we did on the part 1 of this video, the next thing we'll do right now is to now save our structural framing plan separately using a DSF format in AutoCAD. Okay, so with this now, I'll just highlight the plan like this, and then I will then go and then type W, enter. W is a command to save a different work separately. So with this, I will then go here and then click on this icon here, and from the icon there, the next thing I'll do right now is to now save it as a DSF file. Okay, so you come to this place that says file type, and then come here and click file type here, which is DSF. Okay, you can click on any DSF you want, but I advise you always click on the highest DSF that you have. Okay, so I'll click on DSF now, and on this now, the next thing I'll do right now is to not type in the file name. Okay, so I'll come here right now and paste in the file name here. Okay, I already have the file name which I have here, so I'll just come here and then remove this one here. All right, delete that and then just save a different file name, and then click on save. Okay, and then click on okay, that's fine. So with this now, you can see here it is now saved. I'll then go back now and navigate to my folder where that work was saved. Basically, that work was saved under Ekidel videos. Let me just open that up. It was saved under documents, yes. Okay, and then it was saved here. Let me check out for this. Let me see that. No, it wasn't saved here. Yes, so you can see that this is now our file here that was saved. As you can see that, I'll just copy this file now into desktop so that it can be easily be seen. So I'll minimize this. Let me just close this now and then close this here, and then come to this place here and then paste it somewhere here. So I'll just paste that just now. Okay, so on pasting this now, let me just see where it will be pasted. Okay, so you can see it here. So the next thing I'll do right now is now open the file again to now set the drawing at origin. Okay, because when you are exporting DSL file from AutoCAD to Protastructure, it's meant to be saved at origin. That's the best practice, to save your drawing at what origin. So with this now, I can quickly remove this text, or I can choose to leave it if I want. The next thing now is now save this drawing at what origin, because you can see that our UC LCA coordinate is far away from our drawing, so it's meant to be with a drawing. So what I'll do right now is to do what, type L, enter, and then I'll just type what, 0, 0, and I'll press enter. Okay, and then I can just click on anywhere which I want. Okay, so and then click on escape. So you can see that this is now a line that have just been created. Now the beginning of this line at the end here is now our origin. I can see that our x and y coordinate has now been shifted to this point here. So this now becomes what, our coordinate point. Okay, so what I'll do right now is now do what, go and move this drawing now. So I'll move this drawing from here just now. I'll move it. Let me just take from this place here, from a reference point at the beginning of the line here. So I'll move this now, and then move again all the way down to the beginning of the plan here. So I'll come now and then keep this here. Okay, in less than 40 minutes we are done with the modeling. So I'll pick this here and keep it here, and I'll then come and remove this line here. Okay, so with this, I can see that this drawing now is now set at origin. As you can see, our x and y coordinate is now with the plan. Okay, can you see that? So with this now, I will then go back and then we save this drawing again as TDSF. So what I'll just do right now is to come here and close, do as if I want to close the file. Just close the file, and then they will just close the file now. They will ask me to save. I'll say yes, save, and then they will ask me again if I want to change it to DWG. I'll say no. I'll just come again right now and then choose again DSF, and I'll say save again. They'll say they want to replace. I'll say yes, replace that. That's fine. Then I'll say no, don't convert to DWG. Okay, that's fine. So with this now, the drawing now is now set at origin. So it is now time for us now to now go and begin to now model this building, as you can see it here in the Protastructure. Okay, so with this now, I will then move on to the software Protastructure. Okay, so if you have the software, then follow me right now and then walk up with me. So on the software now, I am using the Prota version 2022 version. All right, so if you have lower versions of Prota, let me say 2018, I would advise you move to the higher version, which is more good in designs. Okay, that's fine. So with this now, the first thing we'll do right now is to now import our drawing into this software. So I'm going to go to the place here that says building setout here. All right, now on going to building setout now, the next thing now, let me just come now and then pin this. All right, the next thing I'll do now is to click on what, external reference drawing. So on clicking on this now, I'll allow it to display. Then I'll now come here and click on what, add DSF. Now this is the reason why you must save at DSF. Okay, so add DSF, then navigate to the place out it is on the document. That's where we have that. So now come here and click on what, the file. You can see the file here. Okay, and then I'll then click on what, open here. So on opening now, it will add up the file here. Now then the next thing, you can see that even if we have added it now, our drawing is not yet showing here. So what I'll do right now is to click on what, this place that says what, active. Okay, now if you're using 2018 version, it's a different step altogether. Okay, so right now I am using the new version of what, of this software. So I'll then click on what, this add here. So with this, you can now see our drawing now is now being what, displayed here. So the next thing I'll do right now is to do what, check here that says what, use color. Okay, now because we set at origin, you can see that our building offset is what, at 0, 0. Okay, that's fine, perfect. So with this now, you can see that our drawing has now been what, is now shown on this software, but our structural members that we created on the during our framing, which is the column, is not yet showing here, and also our grid line has not yet been turned to axis on this software. So with this now, I will then go over here and then click on what, import. Okay, so on clicking on import button now, okay, we are going to import those layers that were set, which is the grid line and the column, into this software. And once this software senses that, it will convert the grid line and column into what? Into a structural element. Okay, so right now we don't have a wall. I'll just remove this wall. Okay, and then once I've done that, leave everything as it is as default, and then come here just now and then click on what? Import here. Okay, so I'll click on import just now. Now on doing this now, the next thing that will happen right now, it will now begin to do what? Convert. Okay, convert the grid lines to axis, and then convert the polyline which was used for column layer to column member. Okay, so just give some time. Once it is done, you will see here we say print log, and then you will see that this your close button will now be active for you to click. Okay, so just give it some time. In less than 30 seconds it will display print log here, and then this close now will now be active. Okay, so right now you can now see that our print log has now shown. Okay, and then from the print log now, this is also, you can see that the close now is now being active. So if I come here right now, then click on what? Close here. Okay, and then when you click on close, make sure you click on OK, else don't click on cancel. Okay it first, else all what you have done is rubbish. Okay, so I'll come now and click on what? OK here. Okay, so then give it some time for it to now display the column and the grid line. Okay, so just hold on for a while for it to display. Okay, yeah, so with this now you can now see that our columns is now being displayed, as you can see that, and also our grid lines too has also been displayed, as we have on the drawing file here, on the CAD file here. You can see the CAD file here that we have on the CAD file. You can see there and everything. You can see our columns also, and also our grid lines. Okay, so with this now, I'll then go back to the software Protastructure. Now Protastructure basically has this nature of changing your grid lines to this kind of numbering A, B, C, D, and all that. But basically the right grid line system is to have the vertical members to be what? 1, 2, 3, and then this other horizontal one should be what? A, B, C, D, and all that. Okay, but basically this you can choose to change it after you are done with your modeling and everything. So that's not a criteria to start changing it now. Okay, but to change your grid line, let me assume that I want to change this one right now to 1, just grid line 1. What I'll just do right now is to do what? Click on the grid line, right click, and then do what? Properties. Okay, and then allow it to now display the properties dialog box. So from that place now, we can now go ahead and then change it to the number we want. So with this now, I'll then come here and type what? 1. Okay, sorry, 1, and then come here and do what? Update. Okay, by clicking on update now, it will change automatically right now to what? 1. Okay, can you see that? Then if I also want to change this right now to A, just A, I will then come here and then properties, and then come here and change to what? A. All right, and then come here and do what? Update. Okay, so this is how to change your axis. Okay, so I can choose to just do that now, but just to avoid wasting time, all right, like I said again, it doesn't affect your design without you doing that, but it is a good culture to have your grid line system naming like this: 1, 2, 3, 4, and so on and so forth, and then A, B, C, D, and so. Okay, that's fine. But before we run the design of this structure, we would change that. But from the steps you have seen me do on this tool, you can do that and then change your own perfectly. Okay, that's fine. So with this now, we can now begin to now what? Insert our column, sorry, beams, because we already have our columns. As you can see that from the list of the column here, you can see that we'll have all our columns now being listed, beginning from column 1, 2, 3, and up to column 58. Okay, that's fine. So with this now, we can then begin now insert our what? Beams. Okay, so how to insert beam in Protastructure is to do what? Come to modeling tab here. Everything lies on modeling tab. Now for modeling tab now, we are done with column, and then this is for walls. This is not really your block walls or brick walls. This is for shear walls, that is like a reinforced wall. So since we don't have that on this building, we then move to the next one, to the next member, which is called beam. Okay, so I'll click on beam now. Okay, now on clicking on beam, the next thing I'll do just now is to now begin to put in my beam properties, all right, which is my beam section size and all that. So with this now, I want to begin my beam section size based on the size of my column, okay? And don't forget that our column size is what, 225, okay? And all that. Then also I will then come again right now for the beam depth. The beam depth based on Eurocode, which we are using, either you're using Eurocode or BS code, it says that the minimum depth of a floor beam should be what, 450 in this 450 what millimeter, in the sense that the slab, which if you take as 150 plus 300, which is the clear depth of beam, will now becomes what, 450. okay? So right now I will then come here and put 450. Now this 450 right now is that slab thickness of 150 is being added to this 450 here. So with this now, I can then begin to do what, begin to insert my beams, okay? So with that, I will then click on this place here, okay? And then since I have my beam, all my beams going all the way down to this place, I will then come here and click on this place here, okay? That's fine. So with this now, I will allow you to insert the beams, okay, in less than some seconds. You see your beams being flowing down here, so you can see our beams now. As you can see, this is now our beam. If you can see that, you can see this is beam 9 and this is beam 8 and this is beam 7, okay? So we have just gotten our beams right now on this line. The next thing again right now is to now go here and insert this other one here, okay? So just to be fast right now, knowing that you have already known how your beams are going to run when you are doing your structural framing. That's why from the beginning I said that structural framing is the basics, okay? Don't just come to begin to model. Make sure you spend time on your structural framing, okay? As you can see on our last video, which is the part 1, we spent over 1 hour plus just to perform the structural framing and to understand the structure, okay? So once you're done understanding the structure, the modeling is just for you to just repeat what you have done on the framing, okay? That's just all. And then your loading, which I will show you, okay? So with this now, I'll just repeat what we did on the framing, which is just what I'm doing right now, to just put in my line of beams on the place where we discussed that our line of beams are going to be placed, okay? And then this other one here, this will be a cantilever beam that will be able to carry this other beam here, okay? So whenever you see this symbol of a beam carrying a triangle, let me just show you that, a triangle like this, what it means is that it's a cantilever beam, okay? Now there's what they call end conditions of a beam, which most people doesn't do, and it's very, very important for you to apply end condition, which is the hinge end and all that. So you have to give to a beam the one that will be hinged and the one that will be fixed. It's very, very important for you to do when you are performing your structural design using any software. You must put in the end conditions, which most people don't do. They just maybe, I don't know if they don't get it, I don't know, but it's very, very important for you to do that, because when you are doing manual design, you must have to identify the beam that's a pin connection and one that is a fixed connection, okay, and all that, okay? So with this now, I'll then go over here and then now that. So we have done many videos about fixed and pin end, okay? So you can watch our videos on that and then follow up. It's very, very good for you to follow that up and make sure you don't miss your end conditions, okay? That will be fine, because if you miss that, one of the things is that it makes your building not to be unstable and all that. 2, it makes your building not to be economical. Your client will have to waste money because of the material, all right, and all that, because you assume that all your beams are fixed. And in terms of that, and also because of that, you will see that you will be having more numbers of reinforcement, knowing that fixed end gives more numbers of top reinforcement. So that's the implication you are going to have by having larger numbers of rebars, okay? And that is not really good. It's basically good for you to understand what the software is saying, and don't just jump into software and then begin to use it, maybe because you have watched videos about it or another, okay? That's so bad. Now this beam here, I'm going to remove it because this is meant to be the primary beam, okay? So with that now, I'll remove this, okay? So let me just undo on it, just delete this. So you can see that when you can see why good it is best to do your structural framing, because it makes you to do what understand the building plan. Okay, so I'll remove that right now and make this my primary beam. Okay, as you can see that right now this was meant to be the primary beam. Okay, so I'll come back now. So you must take all this into consideration while you are doing your structural framing. Okay, and all that. Okay, that's fine. Okay, so with this now, I'll then come over right now and then click on this and then go over here and then click here. Okay, that's fine. So again right now, I'll then come again and come now and then place this my beam here all the way down here, break it here because it's going to be supported by this beam here. Okay, and then go again right now and then keep this here. That's fine. So with this now, I will then move on to the next other things to insert other beams. These beams here also to be inserted here from here to here. Okay, that's fine. And then again, we then go again and insert another beam again. Let me see right now. Okay, we have a beam flowing all the way down from here all the way down to this place here. That's fine. Okay, and then we then go again all the way down here and all the way down to this place here. That's fine. So you can see how we are using a live plan, a rebuilding plan. This was actually the plan we designed for a client some months ago and all that. So you can see that here on Ekidel we use real life plan and real life examples to teach. That's because we believe that it is only with that younger engineers can be able to gain confidence, all right, on themselves. Okay, so once you are able to practice what is happening here on Ekidel, I give you maximum 6 months or 3 months, you will be good. At least you'll be able to design 1-story building, 2-story building confidently for a client. Okay, and all that. Okay, that's fine. Then also don't forget to also recommend your friends and colleagues to Ekidel so that they will also know what's happening here at Ekidel, knowing that Ekidel's mission is to do what is to teach the younger engineers and also to stop structural collapse in the world. So I believe by you sharing what's happening in Ekidel and sharing good knowledge to your friends and colleagues, then we will be able to achieve our mission. Okay, so I'll do the same thing right now by providing we have some okay, no, we took all this to be a panel. You can see that panel 13. So all here's a panel, there's no beam running here. Okay, that's fine. And then we also have a beam running from here all the way down here. Okay, that's fine. And again, after this right now, we then go again and then move into from here. So make sure you put the main primary beam first before you now put your secondary beams, else you'll be having all your secondary beams to be having what cantilever signs and all that. Okay, so with this now again, I will then move on to now insert the horizontal one. Okay, then escape now and click on this place here and then move on to this place here and hit his head on the column here. That's fine. And again right now we then move on again and then from here all the way down to this okay, to this place first and keep this here. Now before I insert this one here, I will need to first provide the primary beam out, and I'll escape first and put a beam. Let me say, okay, a beam is going from the way here all the way down here to this place here. That's fine. And again, I'll then go right now and then continue again. You can see that this building is a bit massive, a bit, although not that big massive compared to the ones we have done here on Ekidel for the previous months. Okay, so I'll come again right now and put this. Okay, that's fine. Now the reason why I say it's a bit massive is because we have spent just 22 minutes and then just doing the modeling here and all that. Okay, so I'll do again right now and then do this here. Okay, now you can see that if you want to learn more on Ekidel, I would advise you join Ekidel Premium videos. Okay, that's why we'll have more exclusive videos and all that. As you can see that we used to add more videos every week, more comprehensive and well explained videos on our Ekidel Premium and paid videos. Okay, so you can join Ekidel membership here on YouTube. If you click on the join button on any video you're watching right now, you will see join button. Once you click on that join button, you will see the list of what Ekidel membership, beginning from the paid Ekidel paid courses, then followed by the premium videos, and then followed by the high-rise building, and then followed by Ekidel mentorship. So whichever one that interests you, you can join, but I would strongly advise you join the Ekidel Premium because that will give you access to a so many videos. Okay, now the one that is on high-rise building members is for, you can see that I made a mistake here. I meant to insert first the main beam here. Okay, so the one that is on the high-rise building membership is for those that are already advanced in Protastructure that want to learn how to model or design high-rise building, like with 𝔼𝕚𝕚𝕚𝕚 and all that. Okay, you can enroll, just join that membership plan, and then you will be able to know how to design high-rise building and also more exclusive Pi foundation. Now, a detailed Pi foundation design will be coming on to Ekidel next week on Ekidel Premium. Okay, so for all our Premium users, which you can see if you go to our channel, you will be seeing the list of people that have joined Ekidel and all that. You are going to be receiving a detailed Pi design, okay, on the software Protastructure and all that. And also we are about entering into tower design from next month, which is Max design, right, telecom Max and all that. So, and those videos for the first time will be uploaded first on the Ekidel Premium users and Ekidel paid version members and all that. Okay, so you can see basically how why Ekidel Premium is very, very important for everyone to join and all that. So if you want to grow your structural in design or engineering career, I would advise you join Ekidel Premium. But if you don't have money yet to be paying for Ekidel Premium, you can still be watching the free version here. As you can see that most of our videos here on this free version are very, very good, and it has been helpful to many younger engineers, to students and all that too, and that have really helped them to be designing for clients and all that. And we can see their comments and also their direct messages to our DMs and to our emails, thank you messages and all that. Okay, that's fine. So right now you can see that we are almost done with the beam placement, and this is almost 25 minutes, but I believe before 30 minutes we should be done placing every beams, and then we will now begin with the slab loading. Okay, that's fine. So with this now, we then go over here and then continue again and then put in this beam again from here all the way down here. Okay, that's fine. So again, we then go again right now and then place again. We are almost done with our beams, and then from here all the way down here. Now I made a promise that by 30 minutes we should be done with our beam placement. So let's see if that can be achieved. Let's see if we can achieve that. Let's just hold on about that. Yeah, and then from here all the way down here. Okay, that's fine. We also have beam going through the staircase. Yes, that's because it will help to carry the landing of these two staircases meeting at the same point. Okay, so I'll put this right here just now. Okay, that's fine. And again, I'll then go over now and then escape. Okay, and then there's a beam that was meant to be here from here to here. That's fine. This is 27 minutes currently. Oh, that's fine. And then we then go again and then okay, here, yeah, that's here, from here all the way here. That's fine. So with this now, we have not done this. Let's now check again if there is another one we have not done. Help me and check that. Okay, we have done almost everywhere. Correct. So we are able to beat the timing that we said 30 minutes, and we basically stopped at 27 minutes and 25 seconds for that. So let's now begin to do what? Oh, we are still missing one. That's bad. So right now, just take again beam right now and then insert this other one which we are missing here. I believe it will still be around 27 minutes. I will not allow to read 28 minutes. That's fine. Correct. Okay, so right now we then go over to now begin our slab loading. Okay, that's fine. So we then go over right now and then click on modeling again and then move to the next tab after beam, which is what? Slab. Okay, now on the slab now we will now begin to do what? Apply our what? Loadings. Okay, now as you can see that before you insert your slab, you will be asked to do what? Define your load case. Okay, and all that. So I'll come now and say yes, define my load case. Now from this place now, we will then allow it to load for the next interface where we'll have to do what? Generate our load. Okay, and all that. And if the building is going to be affected by wind, earthquake, this is the time for you to define all that. Okay, so let's just choose the right load, which is basically for the location of this building and also for the nature of this building, which is for a residential building, okay, and all that. So on this page right now, the next thing I'll do right now, which is the loading combination, I'll then come now and then click on what loading generator here, okay. So with this now, knowing that this building is just a one-story building and there is no wind effect on this place, base being that the location of this building is in Nigeria and all that. So Nigeria doesn't have earthquake effects and all that. So with that, there will not be any need for seismic load, okay, and all that. And also there is this building is less than 10 meters high, so with that there won't be any wind effect or load applied to the structure, okay. So we have only the natural load and all that on the building, okay. That's fine. So let us highlight now to now display. Okay, so from this now you can see that this is now the automatic loading editor and all that. Now because of the nature of this building, that this is a one-story building and there is no wind load effect, there is no need for us to go and click here and then activate and then add our wind load and all that, okay. So we will just go back to vertical loads and all that and then continue and just say okay, that's fine. But had it been this building was more than 10 meters high, we would have done applied wind load and all that, and had it been this building was in a seismic area where earthquake occurs, we would have done and designed it based on seismic effect also. Now on our high-rise building, we have started adding videos on seismic design, okay. So you can join that if you want to know how to design seismic structures, okay. Then right now then come and do click on okay here, okay. That's fine. So with this now, our slab tab now will now do appear for us. Now begin to insert our slab. You will see it soon right now on the right hand side of my screen right now. You will see the slab tab will just appear automatically first. Now begin to do input our slab properties, okay, which simply that our slab depth, I want to use 150 depth of slab. That's because the panels of this building are less than 30 meter square area. As I told you guys from the beginning of the part 1, that our area of our slab at least should be less than 30, and since we obeyed that rule, that means that I will use a slab depth of 150, and which is perfect for the design, and there will be no failure based on the slab depth, okay. That's fine. So with this now, let's just hold on for that to appear just now. So from here now, we will now begin to do now begin to add our slab depth. As you can see that the default slab depth here is 120. So I want to add my slab depth to be 150, okay. That is the slab depth you are to consider first. The first slab depth you have to consider is 150. That's the assumed depth. And then our cover can still be 25. So if your own is 0, change to 25, okay, and all that. And then we now move on to slab loads. Don't mind this one that says type. It will pick itself automatically during the design stage, okay. So I'll come now and then click on this place here that says loading, okay. So on this loads now, we will now define our dead load and our imposed load. Now I want you guys to pay attention to this place loading, because we have received so many calls from people and all that in terms of the dead load here, okay. The dead load, most people used to go here and then choose the value which they have here. That's because they are confused on how this dead load is being generated. So they'll come here and choose room, balcony, lower slab and all that, and then it will give them a custom load, which we don't do advise here. So I'm going to explain to you what constitutes this dead load and how this dead load value, how you get their value, okay. Knowing that when you are doing your manual design, you have to calculate your design loads, okay, before you begin your design of any of the structure, okay. So the same thing happens here. So I'll tell you how this dead load is being gotten. Although you are not going to impute design load here, you are only going to impute the dead load, okay. Now this dead load here, the first thing you should know that it is not a factored load, okay. So that most people used to go and multiply their dead load by 1.4 if they're using BS code, or 1.35 if they're using Eurocode, or 1.2 if they are using American code. They go and do multiply that and then impute the value there. What you have just done is that you have done over design, because the value that you are going to impute here, the software will still apply the factor of safety this thing into that load, that means that it will be a double that you have done. Okay, so you have to input unfactored load on this dead load. Okay, now how this dead load is being gotten, this dead load value is gotten based on two values. Okay, the first is the partition load and the second is the finished load. Okay, so the combination of the partition load and the finished load is what makes up what our dead load. Okay, so now partition load basically varies from what ranges from 0.5 to 1.0 or 0.75. okay, then finished load ranges from 1.0 to 1.2. okay, so with that, now if you combine those two values together, that gives you what your dead load of your structure. Okay, so with that, now I want to take my my finishing load to be what 1.0 and my partition load to be what 0.5. If I add that up together, 1.0 plus 0.5, that gives me what 1.5. so 1.5 now becomes my dead load for this structure. So this is how we got, and this dead load is being gotten. So right now I'll type in there 1.5. okay, that's fine. So this is now unfactored load, because the software will use the code that you have chosen to now apply a factor of safety into that load. Okay, that's fine. So on this imposed load now, which simply means what life load, okay, I'll then right click on this place now, and you will see series of load based on the types of structures. Okay, knowing that this is a residential building, all right, so I'm going to pick what rentable general demostrate use. All right, so I'll pick that right now. Most people can pick this, but I'll advise you pick this if you're doing for what residential, because this one here is what limited use. So always pick this one here. That's fine. So with this now, you can see that basically based on the country where this building is to be sited in Nigeria, there is no snow load. And also for the roof load, based on that, we want to use what we want to use roof beams to carry the what like the roofing sheet and the trusses. The beam depth of 300, which I want to use, can be able to carry the weight of the roof without any issue. That's based on experience. So with that, now I will not have to input anything like wind load, and since there is no snow in the country Nigeria, I will not input any factor for what snow load. Else, had it been designing for countries like Canada, US, New York, I would have imputed a snow load of what 2.44. That's the snow load in these countries which I've just mentioned right now, and all that. And if you're designing for countries that is in this Caribbean region, you would have imputed rain load, okay, because they have much rain in that Caribbean region. Okay, but right now we are not designing for any of that country, so I'll leave them as vacant. Now also you can see that this also they are blanks. That's because you have to go and do what check it. Now once you check that on the settings, then here now will not be what inactive. Okay, but right now we are not doing that. Okay, so I'll just skip that and then go and do what begin to insert my slab now by clicking on the panel. So if I come now and click on this panel now, you see that our slab will just do what appear here. Okay, so once you click, hold on for a while, your slab will do what appear. Okay, so with that step, right, you can see that our slab now is now appeared. Slab 1 of what 150 depth. Okay, so with that now I'll begin to do what input my slab by doing what clicking on the panels. Okay, just be clicking and then the slab will begin to do what show itself. Okay, so just be clicking and all that. When you have clicked for a while, then hold on for the software to do what insert all the slab on the panels which you have done what which you have clicked. Okay, that's fine. So I'll hold on now for you to now insert all the slabs on the panel which we have done what clicked. Okay, then right now we will still continue again by inputting our slab on other panels. So I'll click here and then allow it to insert the slab, and I'll click here also here. Let me click on it on this side here, and I'll click on this side now again, and then on this side here on the panel. So with this now we are done inserting slab on just this panel on my left hand side, knowing that this is a twin building. We'll also begin to insert again on the other side too. So on this side here too, I'll also insert my slab here, and also my slab here on this side too, and also my slab here and 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 here. Okay, so our light now insert the slab perfectly and all that. Okay, that's fine. So we are now left with these two panels now inside our slab, panel 8 and panel 5. So I'll then come now and click on this place here to insert my slab, and then click on panel 5 here to also put in my slab once here is done, and panel 5 here. Okay, so with this I can see that we have now inserted all our slabs, okay, and all that. Okay, that's fine. So you have to leave the staircase place to be open because that's a void and all that, although we still have a place here where we need to insert a slab on this staircase area because that's a cantilever which you're going to insert our slab, okay, and all that. You can see that this place here, there's a slab that's meant to be here. If I walk you through right now back to the CAD file, okay, to the CAD file, just here now, let me just open that up. On the CAD file here, yes, you will see that there is a small recess on this place. This place here is being recessed out. Can see that. And if you look at it on the plan view here, yes, you can see that on the plan view. Let me just go here. You can see that this place here, that this place here is now recessed, okay. And if you go to the roof area too, you can see there that here also has a recess, okay, because this at the roof, this is a slab that is going to carry the water tank at the roof floor, okay. That's fine. So we are going to implement also this on our design, which is going to carry a cantilever slab. As you can see from our GA here, a cantilever slab is at this point, okay. So let's now go and do that also. Now for those of you that followed the part 1, you can see how, knowing that before we had a full column that is stretched all the way down from here, all the way down from here, but I now went and divided it into 2. So you can divide your columns into 2 parts like this, because if you don't do this, it will be hard for you to insert your slab perfectly on this side here, on this side. So divide the columns into 2 like this, and then make a small bin to pass through that place. During your detailing, you cannot choose to merge it together, okay. That will be fine, okay. That's just to get your slab in this panel, okay. That's fine. So with this now, let's now go ahead now and then model this our cantilever slab here, okay. So with this now, let's now go here, and then before we begin to model our cantilever slab, we have to do what, have our axis on this place, okay, before we can put the slab here. So with that, I will then go and close this slab dialog box, knowing that we have already inserted all our slabs that we have here. Okay, we still have one slab here to be inserted here, so I'll just right click right now on any slab, properties, and put in my slab here. So you must make sure you look at everything, that you have done all the slabs and everything that you needed on the model. So I'll come now and put in my slab here, okay. And then once that is done, we'll then move on to the fixing, okay, fixing of the beams and hinging, okay. So let's now work on this place here first to put in the cantilever slab here, okay. And then come here and click on what close here first to now provide our grid lines, okay. So to put in my grid lines now, or to get this shape perfectly, I'm going to use polyline to get this shape, okay. So with that now, I'll then come here and click on modeling here. Now on modeling now, just hold on, modeling, once that appears, I'll click on, I can choose to use polyline, or I can choose to use grid line to get what I need. So I want to use grid line actually. So on the grid line now, what I will convert it to ghost axis or hidden axis, okay. So once that appears, I will then move on to choosing my hidden axis here, and remove these bobs on my grid lines, okay. And then I can now go ahead, I want to begin my grid line from the center here, all right, and then come all the way down here. Make sure first I want to get this horizontal one first, from here all the way, hold my control key to make the line straight, and click here, okay. And I can choose to stretch this other end here a bit, okay. Escape and click on that grid line properties, sorry, not properties actually, but stretch, okay. And right click again, and then click on what, stretch here. So on stretching now, I will then come and stretch this axis out to at least a bit this way, okay. Since it is hidden axis, you will see it as if it's very thin. Can you see that? As if it's a trace line, okay. That's fine. And again, click on the axis now, right click and do what, say properties, to take that property of that thing. I'll then come now and click on this place. Now I want my this to align, okay, and all that. So I'll come now and ignore what happened here, and I'll go all the way down here and then click at this point here. Okay, let me just follow that. I'll follow here right now and then click here, and let me just align it, please. I want to align it actually. Then align here and then I click here. Okay, well, just to follow up what is on the model, okay, let me just follow what's on the model. Else the best one is for you to transfer each load directly to the center of the column. That would have been the best, but let me just follow what's on the model first and then come here and follow what's happening there. Okay, so by doing that now, I was need to do was stretch out my grid line from those points. Okay, so I'll stretch now from here all the way down here, and again I'll stretch again from here. I'll stretch again, stretch. Okay, I'll stretch from here at least a bit out, something like this. That's fine. Okay, and then I'll then go again, right click here, properties. Okay, for us to now begin to insert the other one, I'll just again right click and properties here, and again insert this other one here. Click on this now and then go all the way down and then click on this point here. Okay, and then I'll do what? I'll just escape, right click and do what? Stretch. Okay, I'll stretch this point out onto something like this. Okay, that's fine. And I'll go again right now. I'll go again, click on this, right click here and stretch a bit out on the other direction from here all the way down here. That's fine. And again I'll then go right now and then begin to now put in my slabs. Okay, so now putting my slabs now, I'm going to use a method called pick axis, okay, to insert my slabs. Okay, so I'll then come now, click on my slab here. All right, I don't want to use a cantilever slab for this because I already have most of my edge supported with a beam. So I'll just come now and then click on the slab here, right click here and do what? Properties here. But I'll show you how to apply what? Edge load, okay, on the cantilever, on this slab edge. Okay, so with this now, I will then come here and change. Okay, not changing actually. Come now and then pick on this place here and say what? Pick. Not, I can use pick point. Yes, pick point can still work. So pick points. Okay, then I'll now pick a point now. I want to pick let me just check if this point will work, because I wanted to have it stretched down this place, my axis. But if this didn't work, then we'll not have it perfectly stretched. I'll just pick from this point now. Okay, so I pick from this point now and then go to the next point here and make sure you click it directly, which is here. The next point is here. Okay, and then our next point now also is here. Okay, and our next point now also is here, correct? And then we then go vertically right now to go and click our next point here. Okay, and then our next point now goes to this other side here. Okay, let's see now if our slab will show automatically. Let's see that. Yeah, our slab will show now. Yes, correct. So this is now our slab. Can you see that? Correct. So by the time you've done that now, the next thing now we'll do, if now go and check on our 3D view. Now, first of all, before the 3D view, since we have captured everything on this plan, we have modeled the cantilever slab and everything, it is now time for us to now remove the trace. You can see that this because we are still having all these trace of and everything, it is making our plan to look dirty. Okay, so with that now, I'll then come and then go to my building start here and come to a external reference drawing here and then make this to not to be active any longer, and you see that it will just go off and then say okay, that's fine. So you can see that our plan now looks a bit clean. Can you see that? That's fine. So with this now you can see what I've got. Now this, you can see that there is a colliding axis here. Basically, if you go to our CAD file, we made some axis there to be shortened. Okay, if we go to our CAD file now, you can see that we made some axis here. Let me just show you that. You can see that this axis now is stopping what? Is stopping halfway. All right, and this one is stopping halfway. So on this software right now, the software tends to do what? Extend it, which you can see directly here. me just show you that. Okay, you can see that it tried to extend it. So let's now make it to do what shorten. Okay, so make this one right now, right click here and then do what stretch. Okay, we are going to stretch it down now from here, because after this place it is not useful, so it's only useful on this part. Okay, so I can to keep it somewhere here, that's fine. And again, come back now and restretch this one backward, because it is not useful on this end point here. Stretch it backward now from this point and all the way down here. It's useful here, that's fine. So with this now you can see that our this now is no longer colliding. Can you see that? That's fine. Again, let's see again this other one too here. Yeah, we can choose to leave this actually, yeah, or what we can do here to avoid this thing from colliding is to click on this, right click now and properties, right, and remove these bulbs from here. We can choose to remove these bulbs and keep only the bulbs at this point and say what update. Okay, that's fine. So the bulbs only be on the other direction, and here is off. Okay, that's fine. So you can see how it is now. And then this other one too, now click on this right now and transfer the bulbs only to show on one side. Then come here, properties, and then come here and then remove it from this side. Sorry, yeah, and then update. That's fine. So it will only be on the other side, and here will be what free. Okay, that's fine. So you cannot see what you've gotten just now. So make sure that you're not having any of your axis. This same thing happening here. Here now will be stretched downward. So click on this one right now, right click here and then stretch. Okay, and then come now stretch it down to where it is only useful, which is around this place here, and keep it here. Again right now click on this right now, again right click here and do what stretch. That's fine. And stretch right now from this point alone all the way down to here alone and leave this. Okay, that's fine. So you can see right now that it's only useful here. So we are done right now with our modeling on the ground floor. What we are now left with the hinging, which I will show you perfectly later. So right now, if now go and check on our 3D view right now, 3D view here, let me just go close here up. Okay, 3D view right now from here, right click here and 3D view, you can see what we have just achieved just now. We have just achieved what? Achieved all our beams and columns being modeled, okay, perfectly. So you can see our 3D view now we just show right now. Okay, can you now see our 3D view now showing perfectly? If I send down my grid line below just to have a clearer view, you can see how we have just achieved that. Can you see that? Perfect. So this is now the model that we have just achieved just now. So let's now go and begin to model other stuff, because we have not yet done hinging and also the block wall and also insert our story. Okay, so let's now go back to our plan view here. Okay, now on the plan view now, let me now I'll use one day to teach a concept of hinging, because most people don't understand it actually, so I'll not rush it. So the next thing I'll do right now is not go and insert my story, so that I can use one day to teach the concept of hinging. Okay, then after hinging I will now show you how to apply the hinging on the first floor too. Okay, which you are not going to repeat what you have done on the ground floor. Okay, so right now let's now go and do model the upper floor. Okay, so I would like to model it while I am still on the 3D view. Okay, so that you can be able to value and see what's going to happen. Okay, that's fine. So to now to now insert a story, you must have to be on the story you want to insert from. Okay, so I'll go back to my story 1 here, and then to now insert a story, I'll click on model building model set out here, and then click on this place here, on that story here, and then click on story operation here, and then click on insert story here. Okay, now on inserting story right now, the next thing now is to put in my the number of story, which is 2, because I already have story 1 here, and I'll do generate generate members. Okay, alongside. Now you can choose to leave this height first as default, because there is chance for us to change our building height and everything. Okay, and I'll come now and do click on okay right now, and then say yes, continue. Okay, so with this now you see that our we are going to have the next story right now being added just now. Okay, so you will be seeing our next story right now being added, which you will see just now. Okay, you can see that the grid line is there now, bringing the column and the beams now and the slabs. Okay, that's fine. So you cannot see that we now have our next story now being added. Okay, that's perfect, and that is nice. So with this now, the next thing we're going to do is to remove all the slab on the roof area, because this is now the roof area. So this is basically right now, this section here is the ground floor, while here right now is the first floor, and this place here is the roof. Okay, so we are going to remove the slab. Okay, so we are going to go back right now on the story 2 here under our on our tree. I'll just bring in the slab down here by clicking the arrow. Now on the arrow right now, you will see all our slab now will be what listed down. Okay, then I can choose to click on the first one here, then go down and then hold my shift key. You can see our slab now is there. Hold my shift key and click on the last one. Okay, automatically it will not select all our slab now. So with this now, I can do what? I can choose to right click now. Okay, sorry, okay, yeah, right click now and then do what? Delete. Okay, delete our what? Slab. Okay, and then say what? Okay here. Okay, so by saying okay right now, all our slabs now will be what? Deleted. Okay, now knowing that we have removed the slab depth, okay, and knowing that what constitutes the beam depth of 450 is the what? Slab, and the clear depth of what? Beam of 300. So right now that we have removed the slab of what? 150, the beam depth also should be able to do what? Reduce to what? 300. Okay, so right now we will now have to do what? Go back to our go to beams here. All right, I can choose to right click here and then do what? Come here and then do what? Beam table here. Okay, now on this showing now, the next thing I'll do right now is now do what? Subtract my slab depth from the beam depth, which is what? 150. So I'll be having a clearer beam depth of what? 300 alone. So I'll come now and modify my roof beam depth to be what? 300, and then do what? Say okay. Okay, that's fine. I'll then come now and do what? Then say close, because it does not change to what? 300. Can you see that? All the beam depth now is now what? 300. And now come and do what? Say close. Okay, that's fine. Now if I now go back to my plan view here on my story 2, I'll make story 2 active on plan view, story 2 to be active. Okay, now on this story 2 now, you can bear with me that what we are going to achieve, what we want to achieve here is basically the roof beam. Okay, we want to achieve the roof beam here. Now in the course of that, in achieving our roof beam, most of the beams here are not necessary. All right, so we are going to remove most of the beams on the roof. Okay, that's to save cost of the structure and leave only the beams that will carry the all the roof trusses, okay, and all that, and the formwork of the roof. Okay, so with that now, this beam here, there is no need for us to leave this roof beam here. So I'm going to remove by doing what? Right click now and then do what? Delete. So you can look at the ones that are not that useful to carry the truss for the roof. And also on this side too, I also modify what I have here now, because this is basically for the roof. So I'll come now, click on this. Okay, and then click on this and click on this and then click on this other one here and right click and do what? Delete. Okay, and I can choose to now do what? Take my beam to from here, right click now and then properties, sorry, right click again and then properties here, and then go all the way down, click here and then make my beam like this. So this is basically a beam that I feel it's a good beam to carry the roof truss. Okay, so with that right now, I'll just repeat what I've just done. Yeah, I can choose to remove this down, but let me just leave that. Yeah, I can choose to remove it because it's not basically carrying anything. Okay, yeah, so this other one, the roof truss can be here and be here and be here. Okay, that's fine. So I'll do it again here right now. Come again here and remove this other one too. Delete this. Okay, remove that and then come again right now. Highlight this here. Okay, highlight this here and then right click now. They will give me a table of deleting. I'll say no, don't take off columns, only the beams. I'll say yes and then say okay, that's fine. And then I'll then come click on this beam right now, right click now, properties, and then come now and then click here and I'll go here and then click on this. That's fine. So with this now, I'll then move on to doing what now? Move on to right now, and this other side now, I can choose to remove this. All right, let me yes, I can choose to take off this. Let me see, or this can still be there. I can choose to remove this other one here, and no, this should be here. Okay, yeah, this should be here. Yeah, this should be here. This is okay to have, but what I'll do right now is to have this extended outward from here all the way down from here to here. That's fine. Okay, so you just give them enough beams that are major that they can use to place their roof trusses. Okay, that's fine. This other one here would have gone, but let me just leave that. But this other one here can go. I don't need this one here. It's not useful. Yeah, it's not useful. That's okay. And then this other one too will still go. It's not useful. And I'll just repeat what I did on the other side right now. So by doing that, right clicking now, properties, and then come again now, click on this and click on this side. Yeah, that's fine. Again right now, escape, and then come again just now by escaping this here. Okay, and then I don't want to have this here, so I'll remove that. And also this other one too, I don't need that for my roof beam. It's not useful. I'll remove that. Then this is the staircase area, so this have to be there, knowing that we have a slab here that will carry the water tank. Okay, and all that, that's fine. Again right now, knowing that from our CAD file here, we have to modify some columns on the first floor, which is these two columns here. So basically this column after this beam does not exist. Okay, a column, so I have to do what? Remove the column after the beam. So right now, from what we just saw right now, this beam here is not in existence, so I can choose to do what? Delete that. Sorry, this column here, remove this column here. All right, and then this beam also should go. That's fine. And this will go, and the column will go, and this beam also will go, and this beam also here we go. Okay, and then it will now be appearing straight. Okay, so we can now go ahead and then make our beam right now for the roof to be what? Straight. Okay, from here to here. That's fine. Okay, that's okay. That's fine. Let's confirm that if that's what we have on our CAD file, because you must model what you have on your CAD file, and on that, else you change the beauty of the structure. Okay, yeah, you can see that for that on the first floor it is going what? Straight, all the way down straight, while on the other floor there was a small recess. Can you see that? That's fine. So on the first floor, which is the roof beam, is going straight, and if you also look at it on our model here, you can see that it is going what? Straight. Okay, that's fine. So with this now, let's now move on to the next what we have right now. Okay, and then move on to here again and do the same thing here by taking our beam right now from here all the way down here. Okay, and then come now and remove highlights here, something like this. Let me just see. Correct. Yeah, something like this, and then right click now and then say what? Delete. That's fine, and say yes. Take off, and then these smaller beams here are going off. That's fine. Right click and then do what? Delete. That's fine. Okay, that's okay. And then we have now gotten this. So the next thing now we'll do is now model where we'll have cantilever slab. Okay, there is a cantilever slab on the story one on this side. Sorry for that, on this side. So we have to do what? Modify that. A cantilever slab is here. So if you look at the CAD file again critically, that's why you need to have CAD files when you're working or practicing. So if you now look on the CAD file again critically now, let me just go right now on the CAD file here. Okay, you can see that from the wall here, we have some little cantilever coming out, and if you also look at it here on, yes, you can see that this is basically the ground floor. You can see that ground floor. Now take a look at this point here. If you don't have the CAD file yet, take a look at here, and if you look at this place here on the first floor, you can see that we have what? A toilet. Okay, that is here. Now if I choose to copy just the external walls now out, okay, external walls, something like this, something like this, yes, and then copy it right now from the point, let me just say a point here, from this point here, reference point here, and take it all the way down to the next reference point which I have here. You see that our line, can you see there? and then come here and place it here. If I now check here, you can see it. Can you see that now? This is our cantilever. So if I extend this now, let me just take this and extend this right now to this place here. You can see that this now becomes what our cantilever. Okay. So if I copy this now or move it now to where we have our GA, our framing into this place here, you can see that this is how our cantilever is, that is carrying the what, the restroom or the toilet. Okay, so I'll change this now to have what, cantilever symbol by doing this. So we have this now on both direction, even here and also here. Okay, so you can see that also that we also have toilets here. Okay, so the same cantilever length and everything is the same. So right now let's now go and check out for the cantilever length. Okay, so I'll come now and look at this from first. I'll look at this from the grid line to see our offset to the edge here is what, 1262. Okay, and then the actual slab length now begins from the edge of the column to edge of the beam to this place here. That gives us a 150. Okay, so right now we are going to offset this grid line by what, 126 on both sides. Okay, and our slab length now becomes what, 150. Okay, that's fine. So with that now, let's now go and offset this grid line by 1262. Okay, so right now click here, right click and do what, offset. Okay, offset. Okay, by pressing F2 key you can be able to add your value. Okay, 1262. Okay, and then type what, enter key. Okay, now I'll convert this right now to a hidden axis. Okay, so I can know that this is just for cantilever, and then right click now and then come here, properties, and again come now, convert to hidden, and then remove all these bobs. Okay, and then say update. Okay, so with that now I now have this here. Okay, so I can now come now and do the same thing on this other side too. So with this now I'll then have my what, my beam, cantilever beam. Okay, cantilever beam from here all the way down here. Okay, and then again from here all the way down here, but this time it will have to do what, recess. Okay, flush with the what, with the grid line, because this is the end of the cantilever. Okay, so this beam right now meant to do what, flush. Okay, so I'll come now and change the beam orientation to this and then say update. That's fine. Okay, and it will flush. Okay, that's fine. So with this now I'll have to use this beam that is coming from the column to be the cantilever beam that will carry this other beam here. So I'll click on this right now, on this beam, right click here and unsign it as what, as a cantilever. I'll say both ends supported. Okay, that's fine. So like I said again, I'll teach you hinge end of the beams later, because that will be a course on its own later. Okay, so right now we now have a slab here, so I'll come now and click here, right click here and put in my slab there. Okay, and all that. So I'll come now and put in my slab here, having the same load of everything. Okay, and all that. Then just allow that to insert for the slab. Okay, let me just hold on for that to insert. Okay, so we can now have our, can you see our slab now? Okay, that's fine. So we then repeat the same thing that we have done now on this other side here too. The same thing will happen here. So escape now, right click, properties, sorry, offset by what, minus now, because it's going what, leftward, minus 1262. Okay, so offset now, F2 minus 1262. That's fine. Hold on for that. And then do what, either you click or just click. Okay, or you press enter key, anyone will still work out. Okay, so with that now let's now move on to that. Let me just hold on for that to appear and all that. Okay, it's about to appear, just hold on for that. Okay, so you can now see the grid line now is now showing what, A38. Okay, so with this now I will then go and then change it to what, change it to hidden axis. Okay, properties, and then change to what here now, change to hidden axis here, and then do the same thing here and do what, update here. That's fine. So with this again right now, once that appears I'll then do what, close here. Okay, now on closing now I'll just repeat the same thing which I did before by coming here, right clicking now, go here first and put in my primary member, which is the main cantilever beam that will carry the other beam. click on this, and then come again right now, and come again here, click on this now, and come here, and then just hold on for that. Click on this here. Now change the beam to flush directly on this line of what cantilever. So I'll go here, change the beam orientation now, and click on this first one here and update. The beam now will now flush with the grid line, because that's where the cantilever line stops. Okay, so you must follow what is on the model. Okay, that's fine. Then I'll come now and unsign this to be what, to be a cantilever. Let it be what, supported by this other one, which is the main one. Okay, and then the next thing now I will do, basically I would have hinged it now to be a pin end, but like I said again, I'll teach pin end as a separate training, okay, because I will explain a lot there. So I'll come again right now, take my slab from there, right click now, and then come here, okay, and then come here and put in my slab inside this place here, okay, and all that. The next thing now I'll do right now is now going to provide what, a beam on this other side now. Okay, this other side here should have a beam. So with this now, I'll then provide a beam here, but smaller beam of 300. Okay, so because it's carrying a smaller load, so I'll come now, the properties of that beam, come again now, and then take it to be what, 300 here. Okay, and then come first and insert my beam here. This is, let me see. Okay, you can see that we got it wrong. This is actually the place where we are meant to put our our slab. Okay, can you see that? This is the beam we got it wrong. Okay, so we take off this slab now. We take off this slab and model our beam very well and our slab. Okay, so let's now do again right now by clicking on this, by clicking here, and do what now by saying what properties now. Hold on for that. To show to like display, then properties now. Okay, then I'll then go over now and then making it to be what, 300 because it has a smaller weight it's carrying, from here all the way down here. Okay, make it now to flush. Okay, I want it to flush. Okay, then come here and make it to be what, flush. Okay, sorry, flush by this. Let me just see that. Okay, let me see. That should be the wrong one. So come now, use this other one here, update. It's not picking. Let me just hold on for that. Sorry, escape first, then right click now, properties, and then come down and then click here and pick this other one. Let me just let me see right now, properties. That's wrong, so I'll just delete that first. Okay, delete that, and then come now, pick this quietly. Okay, and then insert from here all the way down here. Okay, so yeah, so you can now see how our beam is nice appearing. I'll then come on, do what, escape now, escape. Right, just close here first, and then right click now and unsign this into to be what, not to be cantilever, both ends supported. Okay, that's fine. And then click on this, right click here, the properties here. Okay, properties now, and then come here and then click on this now, and let me choose the different one here, which is to be here. That's fine. And then come here now and then pick on this side now. Okay, that's fine. I'll do the same thing again right now by escaping now, just close. Okay, and properties now, and then do this other one here by changing to this, change to this. Yes, no, yeah, yes, yeah. Okay, let's see. And then from here now, let's see. Yes, that's fine, all the way down to this place here. Okay, that's fine. So we then have our beam now on this place. Okay, that's fine. So we then now go and do what, go and now insert our slab inside this place here. Okay, so we take this beam, this slab properties right now, take it just now, and then come and insert our slab now on those place here. So make sure you look at it very, very well. Insert our slab now on those place here. Okay, just hold on for that to insert. Yeah, we have our slab now being on this place here. Correct. So to this now our slab now. Okay, so if we now go to the 3D view now to now see what we have just achieved just now, you can see, let me just go there right now. You can see that we then have our slabs now being achieved here. Can you see our slab now? Can you see that now? Yeah, correct. So we have not just gotten that now, and we have also added these toilet walls, as you can see right now. Can you see that? Perfect. Okay, perfect. So right now, next thing now to do right now is now going to do what? Edit our what? Story load. Okay, the height of each of the floors. Okay, so we then go now to this place here, minimize, and open our CAD file here. Okay, and look at the section to see the height of our wall of the story, which is headroom to headroom. Okay, you can see that from the basement, sorry, from the from this slab here, which is basically which is the compound level, okay, DPC slab, to the height of our slab here is what? 3050. Okay, but right now what the software requires you is to do what? Is to put the height from slab top to what? Slab top. So to this slab top now, to the top of the top of the slab here, plus the plastering. Let's leave the plastering to this is what? 3.2. Can you see that? 3.2, which is on the story 1, which is the ground floor, and then continue again right now, continue again to the upper, to the next one, which is around this place here. What do we have? We have 3222. Okay, 3222. I know that's the height of this other floor. Okay, can you see that? 3222, but our advice is just maintain 3.2 also, because 22 millimeter is very small. I know that, so just to avoid that on site by during measurement, let's just take a conventional height of what? 3200. Okay, that will be fine. So that means that we have 3.2 and 3.2 as a height, but okay, let's just still maintain what? 3.22 as it is here on the CAD file. But I will advise that during the construction it will be used to be what? 3200. That is very conventional. Okay, that's fine. So right now, let's now they also look at the DPC slab here, sorry, DPC slab, which is the first 3-button level, which you have what? To be what? 600. Can you see that here? Is showing here as what? 600. Can you see that? So let's now go and do what? Edit that too. Go back right now to our software. Okay, and then come now to under here, set out, then come here, story, and then go to what? Edit story. Just hold on, edit story here, which is here, and then begin to now add what? Add our story what? Heights. Okay, first we have what? 600 as our story button level, and then we have what? 3200, and here we have what? 3222. Okay, that's fine, but basically this 222 is not really necessary. For me, I would like us to leave it as what? 3200. That is more conventional to be used. Okay, I know that. Okay, so let us leave this as it is, and then come now and do what? Click on what? Okay, leave this what? Foundation depth as what? Default, because it can change as site. Okay, then come here and do what? Say okay, that's fine, and then say yes. Okay, our building right now we're not increasing what? Height. Okay, if you can see very well, it has not increasing height. So it is now that we have known the story height. Okay, it is now time for us to now do what? Edit our what? Our block wall load. Okay, on the beams. Okay, now before we begin the block wall load, to now calculate our block wall load, let me now show you that our block wall load right now. Let me just carry this beam, this grid line to foundations that you can be you can be able to see very visible, which is what I'm to explain now. Now our block wall load right now, it is going to start from on the first one on this beam, all right, on this beam, all the way down to the bottom of the beam here above. Okay, bottom of this beam here above. So right now, knowing that the height of this story is what? 3.2. okay, the actual height now that the block wall is going to occupy is from the height is from this beam top, all right, up to the bottom of the roof beam here. So knowing that the roof beam now is what? 300. Okay, so the height of the story right now minus 300, that gives us the actual space the block wall is going to do what? Occupy. Okay, so with that now, let's now do that by checking that out right now in calculator, knowing that we have what? We have 3200 as the story height minus the roof beam depth of 300. That gives us what? That gives us 3200 minus 300. That gives us what? 2.9 meters as the height of the where the block wall will do what? Occupy. Okay, so with that now, let's like and do what? Add our what? Our block wall load. Okay, now that we have known the height at which the block wall is going to occupy, 2.9. So with this now, let's now do what? Click on this right now, right click here and do what? Edit story. Correct. Okay, edit story. Now on editing of story right now, let's now it now display a different what? Interface. Okay, so with that I will show you also how to do what? How to calculate your wall unit weight based on your height. Many people feels that 3.47 that that we give here is the actual one, okay, or 2.98. No, it is being affected by the height of your story. Okay, so if someone that has a story height of 4 meters, okay, he will have a different load. Okay, and all that. So with this now, then click on what? Wall load, because that's what we want to what? Add on the beam, wall load. Okay, so on the wall load now, this one's now we do what? Disappear, and we'll have only this. Okay, so just allow it to do what? Load up. Okay, that's fine. So on it loading now, you can now see that we have now want to do what? Enter our what? Parameters. Okay, now you can see that they say what? Wall unit weight, knowing that we are using what? 9 inches block wall, which is what? 225 wall. The one for that is what? 3.47. okay, you can check that out. Okay, we have done many. Okay, how we got this actually is that the weight of one block without plastering is what? 2.85. okay, then if you now add up 0.6 as the plastering weight, you get this value, 3.47. okay, that's fine. So with this now, our height of wall right now is what? 2900. okay, which I've already shown you that. So with this now, we will now begin to do what? Begin to add what? Add our what? Our load. Okay, so once you have done adding right now, then put in your wall thickness here, 225. okay, and then click on the what? Once you put it that, then come and click on the beam here. It will now add what? It will now add the load for you. Okay, just hold on for that. It will show the load now for you. Then come now and then click on what? OK here. Okay, so by clicking on OK just now, you can see that it will show our block wall load now. Can you see our load here? This now becomes our load. Okay, let me just escape now. You see our load now, that the beam now is now what? Loaded. Can you see that? With the what? With the block wall load. Okay, so with this now, I can click on this beam now, which I've already added the block wall load to be fast. I'll right click now and then do what? Copy my wall load. Okay, copy load, and then say okay, copy that only the wall load. Now from our CAD file here, you can see that almost all the beams are having what? Are having block wall load. Okay, you can see that there is no difference between the ground floor. Let me see that. Yeah, between the ground floor plan and the first floor plan. So you can see that it is quite all the beams on the ground floor area here, which is the story one, is carrying the wall load. Okay, above. Okay, so all the beams now are carrying wall load. Even the smaller one that we have here is also carrying what? A wall load. Okay, so with this now, let's now do what? Go back to our software. Okay, then to now add wall load now on all the stories, what I'll do right now is to make my story 1 active. Okay, make story 1 to be active, because currently we are on story 0 that is active. Make story 1 to know that the reason why I choose story 0 was to have a clearer view of my what? Of my grid lines not affecting. Okay, so I'll make story 1 to be what? Active. So let's just allow it now to what? Display. Okay, so right, like I said, that our story 1 right now is now being what? Active. So with this now, I'll then go do what? Click on the beam here and click on the first beam here, go down and then click on the last beam by holding my shift key. So hold your shift key and click on the last beam here, and then with that now, I'll then come now and then I'll then come now, hold on for that. I'll then come now, and once that is done selecting all the beams on the ground floor, hold on for that. You can see that is trying to select all the beams. Okay, so with this now, I'll then rotate a bit. Okay, and then I'll then go right click now, sorry for that, right click and then come now and then click on what? Paste load. Okay, because we have already copied the wall load which you have done, so I'll paste the load now on all the beams. Okay, I know that is okay, that's fine. Now click on what? Escape. So you can see that all our beams now are now carrying what? Wall load. If you can see that very well, can you see that they are all carrying what? Wall load perfectly. Can you see that they are all carrying wall load? Okay, so you can see that very well, they are carrying wall load now, but there are some few beams here that are not carrying wall load, okay, which are this beam here is not carrying wall load, as you can see from the CAD file here. From the CAD file here, basically, let me just minimize this. From the CAD file here, let me just open that up. From the CAD file here, this beam on purple is not carrying wall load because we just added this to be able to break this panel, okay. So here it's not carrying wall load, and here also is not carrying wall load. So these two beams now are not carrying wall load, okay. So I'll come now back to my software here and then remove these beams from carrying the what? Wall load, okay. This beam here and also this beam here also is not carrying wall load. So I'll come now, right click the beam now and do what? Say delete load. I'll say yes, delete the wall loads. That's fine. So you can see that it will just go off. That's okay. So this is now what we have just got. This is how it is. Can you see that? This is how it is. So with this now, we have now done what? Modeled what? The story. And you can also see the toilet wall here. As you can see that we have done that already. Can you see that? Correct. So with this again now, let's now begin to do what? Begin to now do other things. So you can now see our model now has now appeared perfectly and all that, okay. Okay, that's fine. So the next thing that we'll do right now is now begin to do what? Is now model the slab on this area that will carry the what? The tank for the water, okay. Knowing that from our CAD file here, we have on the roof side, you can see that from the roof side here, from the roof plan, we have around the staircase there, we have what? We have a water tank there that is carrying what? That is carrying the water. Can you see that? So with this now, we have to do what? Model this also. Can you see that? So with this, I'll then copy out this right now. Copy this out, this water tank out just now into our GA drawing. So I'll copy this out right now, following this point here as my reference point. This point here, correct. Let me see that. Yes, that's fine. And then move it now, just copy it now to where we have our structural framing here on the roof side. Let me just I can just put it anywhere actually. So I'll come now and then keep this here, okay. Keep this here, that's fine. So with this now, you can see where we have our water tank here, okay. So let's now begin to do what? Model a slab here. All this place has a slab on the roof, okay. On the roof here they have a slab, general slab, okay. So with this now, let's now go, and also you can see that on the roofs area here, which is top one, there is no beam that is crossing like this. So we are going to remove this beam also on the roof side on our model, okay. So let's now go back to our model now and then remove that beam, okay. This beam here is not needed, this other beam here is not needed. So I'll come now and then remove this beam from our model. So take it off entirely by deleting it, okay. So we have a full slab running all the way down here, that's fine. So I'll come back to my plan view now. Now on the plan view, we now go back to what? Story 2, which is the roof area, to now begin to model what? Model our what? Our slab for the what? For the tank of water, okay. For the water. Now this place now, we can choose to generate what we have, that beam we have on the ground floor onto this place, okay. So I'll just go right now by going to this place here, okay, to back to story 1, okay. Now on this story 1 now, I'll then come here, click on this beam and click on this beam here also, and click on this beam here, okay. And I can choose to, just these two beams, and even this slab, no, leave this slab, just the beams. Then right click now and then do what? Generate members onto the other story, and then dot replace if there is any, and then say what? Okay. Automatically right now it will just copy the beam on the ground floor down to the upper floor. Now if you are having 2018 version, you cannot do this. You don't have this command or this option to do that. So you can so I would advise you upgrade to what? Higher version of what? Protastructure, okay. That's fine. So with this right now, then come here and do what? Click close now, and you will see our this thing here. I'll then click on this place now, click on these beams now, and then remove the load. Okay, and all that. I will take off the loads now by coming here, delete loads. Okay, and then come here right now and then do what? Say okay here. That's fine. So with this now, I'll just come here right now and then supported both ends. That's fine. Okay, and I'll come now. So then right now that we now have our beams, let's now go and do what? Go and now model our slabs. Okay, so on our slabs now, knowing that from the CAD file all those places here are meant to be having what? Slabs. Okay, that's because it is going to carry what? A tank for water. Okay, as you can see it here. Okay, so all these places now are having what? Slabs. Okay, now even if from the plan here there is no beam crossing, but because of the tank, okay, at the bottom of every place where the tank will sit, I'll have to have my beam being crossed. Okay, so I have my beam crossed this side and also crossed this side. Okay, that's what I'll do. Although I can still do that by just having dividing this place into two parts like this. So right now what I'll do right now is now do what? Take my line and then take the nearest. You can take this grid line here. The first thing I'll do is to do what? Divide. Let me just remove this this line here. I don't need that for now. And then divide this tank by 2 like this. Okay, because I want to place a beam in between them. Okay, and then get my offsets from here all the way down here. Just watch out, down center, and I have what? A length of what? 3012. Okay, so I'm going to offset that 312. Okay, so I'll go right now and then on my model here, offset this 3012. Okay, offset. Okay, offset what? 3012. Okay, and press what? Enter key. Okay, on doing that now, this is the actual one here, so I'll have to convert it to what? To ghost axis, just not to be confused on that. So I'll come now, click here and click here and click here and click here, and then do what? Update. Okay, that's fine. So this one right now that looks solid becomes my what? The line which I want to use. So with that now, I'll then come and put a beam in between that place. Okay, that's fine. And then okay, and then click on this place here and then click on this place here. Now this beam now will be what? 450 depth. All right, for now. Maybe during the design it might be 600 because of the weight of the water that is coming there. So let me just go that way and then put what? 450 first and do this. Okay, that's fine. So with this now, I would come now and put my slab here. So one tank is here and one tank is one other tank is here. Okay, that's fine. Okay, that's fine. So with this now, how to now model a water tank? If you have a tank of water on the roof of a structure, just as you can see from the CAD file here, around the roof here, you can see that on this building, okay, we have a tank of water on this place. And if you check out the plan, the roof plan of this, you can see that we will have 2 tanks at the roof level. Okay, basically there's a slab here that's going to carry it and all that. So with this now, how to now model these 2 tanks, okay, on the software Protastructure is that the first thing I'll do here, which I've done, is to do what? Divide this place right now into 2 parts. Okay, into 2 parts with a beam. So a tank will be here and a tank will be here. Okay, so with this now, the next thing I'll do is to now put a slab here and put a slab here. Okay, so I'll come now and then go to my slab modeling here and then do what? Slab here. Okay, and on that slab now, the next thing now, once the slab icon shows, which we should just see just now, I'll now go and do what? Put in my slab thickness. I want to use 200 for my slab thickness because it's carrying what? Water. Okay, and then cover, since there is water, I'll choose what? 50 for that. Okay, so that it will not affect the all the bars, all the rebars for the what? For the slab, because knowing that there's a water here tank, there might be this decking or this slab might be wet always and all that. So then on the loads now, the load area, Okay, on the load now, the next thing I'll do just now is now begin to put in my loads, okay, which to calculate the weight of your water. Okay, since just hold on for that first. I'll show you that for now. Click on this load first. Okay, now on this load right now, the dead load now becomes the weight of the tank without water. Okay, while the live load becomes the weight of the water. Okay, so the dead load now becomes the weight of tank of the tank without water, which is the reservoir, while the live load now becomes the weight of the water. Now the weight of the tank is actually gotten. I would take 1.25, okay, for the weight of the tank. Now the weight of the water, this is the weight of the empty tank, so the weight of the water now is what you're going to consider now. How to get the weight of the water? That takes you back to the geometry of the shape of the reservoir or the tank. Okay, so right now let's now go back to the geometry of the tank, which is on our CAD file. Okay, now from our CAD file here, and I can see that the geometry of the tank here is what? Circular. Okay, can you see that is circular? So I can choose to do what? Copy it out just a bit like this. I'll copy it out now, just one of them, because they are the same. So just copy one of them right now. If I copy one out now, the next thing I'll do is to do what? Since it's circular, which is what? The geometry, I'll have to get the area of what? Of this. All right, the area of this circle. So with this now, the area of this, what I'll just do right now is to do what? Get the radius first, the radius of the what? Of the circle, and then do what? Pi r square. Okay, then do this now from the center here to this will give me what? The radius of the what? Circle, which was 770. Okay, 770 what? Millimeter. Okay, that's fine. And I am working with what? Meter. So that give was 0.77. Okay, so QC right now, which was calculator. Okay, calculator right now will now display, and then I will now go what? Pi r square over what? Just pi r square. That's the area of what? Area of circle. Okay, pi r square. So right now pi now is, first of all, let's do let's do r square first, which is the radius 0.77 multiplied by what? Either square root or just say times again 0.777. That's what the square. That gives me what? 0.59 something multiplied by what? Pi, which is what? 3.14 okay, and then equals to what? This gives me what? 1.8. You can see that 1.86. okay, this now becomes the area of the tank. Okay, this is the area of the tank. Okay, now the area now, this is the area of the tank now, correct? Now multiply by what? By the height of the tank. Okay, the height of this tank now, let's now go and check out that of the tank now is what? From this place here, you can get that from here. The height of the tank now from our slab here up to this place here is what? 1.8. Can you see that? 1.8. okay, 1.8. So with this now, this is now the area. Okay, this now becomes what? Times multiplied by what? 1.8. okay, that gives, sorry for that. So we have what? We have first we have 1 point. Let me just copy this now. Let me just double click on this. So multiply by what? 1.8. That gives us what? 3.3. okay, now multiply by what? By the density of water, which is what? 10. okay, 10 is the density of water. Okay, so times 10 now multiply by what? 10. okay, that gives me what? 33 point what? 33.7. sorry, 0.5 let me say 4 approximately. 33.54. okay, approximately. So with this now, takes us back to the volume, the 33 point what? 954. yeah, 532 actually. okay, 53. Let me say 54 because 2 cannot be enter. 54. And then with this now, we'll now come and put what? Put in the load here. Okay, and also the load here also, okay. So with this now, we now change the, we will have to change the depth of the beam around this place from 300 to what, to 600. Yeah, 600. So I'll change all the beam depth here to what, 600. So I'll do that right now. It would have been 500, but I want to use 600. Okay, so 600 right now. To change this now to what, 600. Okay, and this also. Then right click now, okay, then properties, and change it entirely to depth of what, 600. That will be fine, 600, and then do what, okay it here, that, and then close. Okay, so with this now you can now see how we have done what, modeled for the for this slab that's going to carry water tank, and we have also done the what, accounted for the load. Okay, so that's fine. So in our next class right now, we'll now perform the structural modeling, design for this, and also account for other things which I have not yet accounted for. Okay, so you can, so but know that on our next class I'll be showing you what hinging alone. Okay, that will be hinging, how to apply end conditions and hinge on the beam, because it's very, very important to like do that. Okay, so right now that you have come to this end, if you have not subscribed to our channel, please try to subscribe, and also give this video a thumbs up. Okay, give us a like, okay, on this video, and also share to your friends and colleagues. Okay, that's fine. So thank you so much, and God bless you to this end. And also find a way to join our Ekidel Premium. It's very important if you want to know structural design very, very well, because most videos there are very detailed and explained. Okay, and all that. Okay, so bye for now, and then see you again by this time next week. So goodbye, and then thank you for that. Bye then. If you want to learn structural design, then Ekidel is the best for you. By clicking the link, you are already one step ahead. Don't miss this offer. Enroll now.